This is Hacker Public Radio episode 3419 for Thursday, the 9th of September 2021. Today's show is entitled Linux Inlaws S01E38 Tiny Kernels and is part of the series Linux Inlaws. It is hosted by Monolithic and is about 62 minutes long and carries an explicit flag. The summary is all you ever wanted to hear and more about micro-kernels and other operating system war stories.
This episode of HPR is brought to you by anhonesthost.com. Get 15% discount on all shared hosting with the offer code HPR15. That's HPR15. Better web hosting that's honest and fair at anhonesthost.com.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy Mom? Thus, the content is not suitable for consumption in the workplace, especially when played back in an open plan office or similar environments. Any minors under the age of 35 or any pets including fluffy little killer bunnies, your trusty guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs.
What's our box then? Welcome to Linux Inlaws. Martin, how are things?
Oh, things are not bad. Apart from England losing the European Cup. But there we go.
Football.
It was expected, of course.
Was it? Who won actually? Netherlands?
No, Italy. Yeah.
Italy? The amateurs? Are you serious?
They spent quite a lot of money on football in Italy. Yeah.
Well, you see, I mean, fair enough. As we all know, the fortune of the championships is decided in Sicily. So when a couple of old folks talk about this and then decide on the outcome, so it's not about kind of 22 people in a running around in a stadium or something like this. No, it's it's some old people in Sicily rigging the whole thing, so it just makes sense. Actually, that Italy did win it for a change.
They have done in the past. Well, I'm surely more frequently than England. That's for sure.
You see, Martin, that would imply that I know that I know soccer. Which fortunately or unfortunately depends on the point of view. I don't.
Mm-hmm. It can be pretty boring. So.
Yes,
indeed.
But this is not a soccer podcast, but rather a podcast between open source software. Yes.
How are you anyway?
I can't complain actually.
Okay.
Yeah.
No complaints about the beer temperature today?
No, for a change, not. No.
Okay.
Still 8 degrees and enjoying it. Yes.
Good.
Martin, marketing sent you the memo, right? That actually
marketing. We have marketing again. What happened?
Yes, because me, as a matter of fact. No, you see, one of their first actions actually after they started on the 1st of July. Apparently, HR didn't send the memo. Anyway, it doesn't matter. This episode was supposed to be about micro-kernels, But marketing had this brilliant idea of to change this to behind glass painting. I had a telco with them yesterday.
I hope it's open source glass painting.
That's exactly it. So that's specifically the question that I asked them. What does behind glass painting have to do with open source? A question that they couldn't answer, but insisted anyway on changing the subject regardless.
Okay.
That leaves us with the conundrum, actually, either to talk about the subject that we don't know squat about, like open source or micro-kernels, or behind glass painting, which we know a lot about. Or was it the other way around? I can't remember.
Yeah. Well, I don't know about you, but I've certainly never painted any glass. Well, not on purpose anyway.
Maybe behind glass painting, as in you have to move behind or you have to paint it behind the glass. I don't know, or the other way around. I can't remember. My mother taught me about 40 years ago.
Oh, right.
That's all down the drain by now. As in water on the bridge. Because in contrast to other people, I don't practice it every second day for some reason. So why don't we do the following? Just let's fly under the radar.
You say this, but I bet there's never been a glass painting episode on Hacker Public Radio before. So,
I do not know, as a matter of fact. Ken, if you're listening, please write feedback at linuxinlaws.eu, just in case.
Please make a glass painting episode, yes.
Okay. So we might as well actually fly under the radar of marketing and do this microkernel episode regardless, or operating system episode, whatever. Especially kind of with the open source focus. And if they act up, Martin, just fire them again. That's okay, no worries. As you have done many times before, I might add.
Yeah, no problem.
Okay, so this episode is all about operating systems, let's put it this way, with a special focus on microkernels. Full disclosure, I did a PhD on reflecting on operating system architectures.
So you are the expert.
It's a bit of a home run, yeah, let's put it this way.
Cool. So if we invite Mr. Tannenbaum next time, then you'll be happy to.
So who's this Mr. Tannenbaum you keep talking about?
He wrote many books on operating systems. Yes.
I can recall
one of them. Yeah.
I can recall only one, as a matter of fact.
Oh yes, what's this called then?
Modern Operating Systems or something. I can't remember the exact title, but he signed my copy regardless, I think.
That's nice of him.
And that was the last time I saw him, about 30 years ago.
Okay. Well, there you go then. So any authors out there, don't sign your book to Chris because you'll never be seen again.
Full disclosure, I co-wrote the first German book on Mark III, which was a more popular microkernel at the time. And that got me to a Usenix conference where actually I ran into said Mr. Tannenbaum for the first time in my life. And we had yes, that was in 1993 in Albuquerque, New Mexico. Ages ago.
Yeah. I mean, even Usenet, blimey.
Sorry, Usenix. Sorry, did I say Usenet? Usenix, as in the as in the Unix whatever association.
Oh,
ancient history.
I thought about Usenet, which used.
Sorry, Usenix. My mistake.
Okay, no, that's all right.
That was 93. Yeah, it was the. I think if I recall correctly, that was the annual Usenix Systems Conference or something like this. People look it up. This is what the Catfeed network is for. And this is basically where I ran into Andy. And that was prior, actually, to...
Did you say sign my book?
Yes, that was prior, actually, to the Usenix wars, which we will to the Usenet wars, sorry, long day, to the Usenet wars on Linux versus Linux, which we're going to cover in a minute, I suppose.
I think we should, yeah.
So why don't we do a short historical wrap-up, which will take us about 2 hours? So if you want to skip this, people, just fast forward to...
Before we start on the history bit, why don't you tell us why this... why did microkernels came about?
Well, that was part of I thought that was part of the history session. As an history part of the session, sorry.
Yeah, but then you're kind of setting the scene for the listeners why this is...
sorry, microkernels came about because somebody had a brilliant idea of do more compartmentalization on an operating system level. Simple.
And why did they decide this?
some crap about portability, lower the technical depth and all the rest of it. Read it up, people. It's all out there.
I thought you were the expert.
Okay, Martin, does the concept of fashion ring a bell?
Fashion.
If it doesn't, just take a look at your wife or girlfriend or both. They'll be more than happy to fill you in about that concept. So
Right.
Fashion, for the uninitiated, these are trends, especially in apparel, that come and go. There are whole books written on this. There are a lot of books written on the subject. There are endless TV shows covering the whole thing. And funny enough, fashions also have a certain impact on something called technology, believe it or not.
Uh-huh. So what you're saying is that there is no benefits to a microkernel.
We're getting there in a moment. Martin, if you wouldn't keep interrupting me. No, let's start at the very beginning. Okay, Martin, you must record it well. It's mid-60s. IBM had No, you can't. Why? I thought you were right.
No, I wasn't. I'm afraid. Yeah. Can't help you.
Anyway, it doesn't matter. It's mid-60s. A company called IBM has just revised their assumption that 5 computers would do the planet nicely, and are seriously getting into this computer game. What started out as a mechanical endeavor quickly turned into, especially after the invention of something called transistor, turned into much more electronical approaches. Let's put it this way. And with the higher integration of said computers, the need for a more, let's put it this way, structured approach to writing software came about. Hence the notion of operating systems that would clearly separate applications from the underlying hardware.
Mm-hmm. You missed the phase there anyway.
Martin enlightened me.
Between the mechanical and the transistor were the bulbs, right?
Yes. In the interest of time, I'll skip this because otherwise we wouldn't be talking about 2 hours, but rather 4.
Okay. Short episode then, isn't it?
Fast forward to something called 1972, when IBM had not only copped onto the fact that the operating systems are great, but you would be, because the computers at the time manufactured by that company were very powerful machines exhibiting about 4 kilobytes of main memory and a couple of megabytes of hard disk storage. Of course, the idea at the time was to make use of said hardware for not only one application, but for multiple applications. So a few
hard drives in 1972. Okay.
Yes. Or tape drive? I think the first disk was invented kind of late 60s. Before that, of course, they had tapes and
that's just
what do they call, punch cards.
My uni, which was well past late 72, but it doesn't mean that the hard disk didn't exist.
But then you went to uni.
Very expensive.
But then you went to uni about late 50s, right?
No, this was when was that?
61?
1986. Yeah, 1986. Yeah.
Oh, you did adult education, okay? As in kind of after your first job or something. I see.
No.
Fair enough.
Anyway, so
fast forward.
You were saying
yes,
1972. Yes.
1972. IBM invents something called the virtual machine, and the rest is history. As usual in history, things tend to repeat themselves. Now, the shocking news, things may look different, but at the end of the day, they're still the same. So technology has just progressed a little bit over the last, 50 years? So yes, of course, integrated circuits have become much more compact. We're talking about nanometer technology now and all the rest of it, but at the end of the day, operating systems have had a few breakthroughs, but at the end of the day, it's still kind of software running between applications and hardware. Simple.
Mm-hmm.
And with that, we are moving into the picks. Sorry, the boxes,
Yes.
rather, as in the picks of the week. No, jokes aside. Okay, it's 1972. IBM has come to the conclusion that because of the number of operating systems that they had running on their kit, they would need an abstraction layer to allow said operating systems run concurrently on a single machine. Because as today, or comparable today, IBM was still obsessed with making a lot of money. So at the time, they still sold their mediocre hardware, especially in today's terms, for a lot of money. So instead of companies or universities buying quite a few of them, they only could afford one. So that's the reason actually why they put something called a virtual machine on the machine, on that hardware, allowing them to run multiple operating system instances concurrently. So even then, you had the precursor to something called MBS. You had something called the disk operating system, hence the name, disks, and all the rest of it. So that was the first kind of instantiation of, if you will, of a virtual concept, like abstracting away from the hardware and allowing or simulating from the view of a guest operating system virtualized hardware, let's put it this way. What happened simultaneously in terms of concurrent developments, quite a few people, late 60s, early 70s, got together and developed an operating system independently and as an outside of IBM called Multics.
Say again, what was it called?
Multics.
That's
one of the first kind of smaller mainframe time-sharing operating systems. IBM already had the notion of something called TSO, time-sharing operating system, which I think they branded subsequently. The idea was on your typical MVS instance, you would have time sharing, as the name implies. So you would have potentially thousands of users accessing a single MVS instance. Quite a few companies came up with similar concepts. Multics was one of them. I think Multics actually was a university of development. Details maybe in the show notes. But Multics had one trait. It served as a blueprint for something called Unix, which was developed by AT&T early 70s.
Mm-hmm.
And Unix, running initially on things like a PDP-11, subsequently a VAX, was one of the popular mini-computer multi-user operating systems at the time.
Well, you can run Linux on a VAX as well. Okay.
Yes, you can, of course. Digital marketed this as Ultrix.
Yeah.
Years ago.
BMS, that's
yes.
Right.
Years ago. And of course, they had a competing of called VMS Go, which we will go into in a minute. But first, let's cover Unix. Unix and its friends had one important notion comparable to, or one important trait comparable to Multics and all the rest of them. They were monolithic kernels, as in it was essentially one big blob that on the one side abstracted away from the hardware, and on the other side gave applications an interface to talk to the hardware. Mm-hmm. In addition to administering resources, making sure that applications are executed in a fair way, so that not one application could hog out of the hardware, but rather that each and every application would get a slice of the available CPU capacity and all the rest of it. Mm-hmm. Set operating systems would also basically provide something called a file system, where you wouldn't have to access the blocks of a disk or another storage medium sequentially or directly, but rather could associate data with a so-called directory entry.
That's a good idea, wasn't it?
Indeed. Which, of course, other companies like Microsoft ripped off completely when they did something. Oh, sorry, Microsoft didn't do, of course, MS-DOS, because, as probably we all know, Microsoft simply bought something called QDOS and just marketed it as Microsoft Disk Operating System. But that's another story for another day. Fast forward, Berkeley did a re-implementation of said Unix, which is now known as something called the Berkeley Software Distribution, BSD. But all of these operating systems had one thing in common. Monolithic operating systems becoming larger and larger and larger the more functionality you put into them. Mm-hmm. Fast forward to the early 80s. Digital had just created the successor of something called the PDP, called the VAX, VAX. I can't remember what it stands for.
VAX, mm-hmm.
But which virtual something or other. You find the details in the show notes, I hope. But wasn't exactly happy with the operating system run on its successor on its predecessor rather called the PDP-11. So Dave Cutler, digital engineer, sat down and architected something called the Virtual Machine System. I think it's called VMS. That was the first commercially, in brackets, available microkernel. The idea behind the microkernel was to have a thin layer abstracting away from the hardware and then have compartmentalized subsystems running on this microkernel, on this thin layer of that simply abstracted the hardware away. So in contrast to the monolithic operating systems, this thin layer would merely provide a hardware abstraction. So where you had different, say, for example, drive technologies, it would provide a common API towards the different subsystems running on top of it that would make the disks pretty much look alike. I'm simplifying, but essentially that works. That was, or that still is, the way it works. Same goes for other hardware like network connections or like network interface cards, input systems, and all the rest of it. So that is the general idea behind a microkernel. The idea, of course, being that you could have not only one subsystem running on top of the microkernel, but having more than one. So that was the overall idea behind the microkernel at that time. Now, at some stage, they've got a defector called to a company called Microsoft. Probably that probably rings a bell. Who at the time had just progressed from this QDOS thing called from this QDOS derived thing called MS-DOS to something called Windows. Or we're just about to, let's put it this way. We're talking early 80s. Well, MS-DOS was essentially, what's what I'm looking for? Instantiated, not derived, but thought up early 80s. I mean, IBM was looking, okay, the full story, and this is common internet lore. IBM was looking for an operating system for its newly invented, that's what I'm looking for, or was looking for its newly invented PC line. As in an Intel chip with the name of 8088. As in 16-bit architecture but 8-bit bus. They checked with the digital research guys who manufactured CPM for the Zilog Z80 at the time, but the proprietor and his wife, so common law goes, were threatened by the fact that IBM people showed up and the first that they put on the table was a non-disclosure agreement. That scared them away. Huge mistake, as it turns out later. Because the initial deal that IBM had in mind to put CPM on that personal computer of theirs didn't really check out. Then there was this small company called Microsoft on Albuquerque, New Mexico, who got wind of the story and said, we can, of course, provide you with an operating system for said PC line. Fun fact, Bill Gates and friends never had the technology then and there, but managed to convince IBM regardless. Now, of course, they were looking for an operating system that they could put on their machine, searched high and low, and came about more or less a prototype called QDOS, Quick and Dirty Operating System, which, funny enough, could run on an Intel 8088, and also 8086. They bought essentially the right, including the source code of that QDOS, and marketed this as the Microsoft Disk Operating System, subsequently known as MS-DOS. Now, what also happened during the course of the 80s when Microsoft did this, companies like Apple, Xerox, and other visionaries, including Silicon Graphics, I might add, came up with the idea of putting a GUI, as a graphical user interface, on top of their Unix systems. Mm-hmm. Sun also helped along, let's put it this way. So Microsoft was especially with regards to the competition with Apple in dire need of putting also a graphical user interface on top of something called MS-DOS. Hence, this whole notion of Windows 1.0 was born.
Yes, I remember it well. It was completely useless.
Indeed.
You're better off just with plain DOS if you've so, yeah.
Yes, and it became quite clear, actually, that given the fact that IBM put more and more resources into this personal computer technology line of theirs, it would become quite clear that eventually this whole cobbled together technology stack wouldn't suffice. So Microsoft made one smart move at the time. They asked Dave Cutler, the inventor of ZVMS, to join them.
Mm-hmm.
That must have been, I reckon, early 80s, something like that. So what Dave Cutler did, apart from hiring a few university people, he brought also along his ex-digital, some of his ex-digital team. Among the university people he hired was Rick Rashid from Carnegie Mellon University. Rick Rashid was actually one of the brainchilds behind something called Mark III, which was one of the research microkernels at the time. We're talking still the kind of late 80s. So Dave Cutler was commissioned with the task of developing something called the next big thing, like a true operating system that wasn't based on QDOS, or subsequently known as Microsoft Disk Operating System, with a graphical user interface on top, but rather something that would look like a much more real operating system. IBM also had this
graphical operating system, right?
Yes, IBM also had this technology of called OS2, which was still a monolithic kernel, but given the fact that IBM was, and to a certain extent still is, under the impression that not everything that they bought eventually checks out, and I hear that there are still voices at IBM that think the same of Red Hat, but it's of course a totally different story. Suffice it to say, they put some money on the table and developed something called OS2 internally. Microsoft provided some of the stack to this, but not an awful lot because most of the stuff was done internally. But IBM managed to, because IBM eventually got wind of the fact that Microsoft was doing their own new operating system, funny enough called New Technology, because for Microsoft, this whole micro-kernel thing was new technology in terms of a proper operating system for a change. They managed to wrangle the commission from Microsoft that Microsoft, in addition to a Windows personality, and we're going to get into what a personality is in a minute, managed to wrangle the commission out of Microsoft that in addition to a Windows personality, they would also do an OS2 personality running on top of this new technology operating system that Microsoft was just doing as in DevCut internally. So that is the reason why you have, with early versions of Microsoft, especially 3.5.1, you still have that OS2 personality running on top of the microkernel. So what Dave Cutler eventually did, he did I'm almost tempted to say, a spin of VMS. He constructed a microkernel that was just a thin layer on top of the existing PC hardware, but provided an API to run certain so-called personalities on top of that microkernels. And one of them was Windows, another one was OS2. And of course, the third one would be a POSIX compliant CMD-like interface, pretty much like a terminal emulation you would have with the early DOS versions. So this new thing called Windows New Technology, short Windows NT, was born early 90s.
Did you know that the original NT name came from the target processor, which was the Intel i860 apparently?
Interesting, because I thought NQ was standing for new technology.
No, that was later sort of added as a marketing spin, but it was.
I see. It makes sense because for Microsoft it was new technology.
The i860 apparently had a code name of N10, which is well,
Interesting.
yeah. But
because
not a very well-known fact, but it's handy for a
no,
pub quiz. Yeah.
very much so. No, because originally they targeted 8086 and to a lesser extent 8088 with that. Because 8088 was simply not powerful enough to drive that microkernel. Now, what also happened actually on the other side of the galaxy, I'm tempted to say, that there was a company called Apple that did quite a few interesting things in the 80s. Came up with graphical workstations called Lisa. Some people consider it to be stillborn. But also something called a Macintosh, which of course, as we all know, wasn't a stillborn when it comes down to commercial success. Now, as I said...
if you compare it to IBM, then it wasn't really a success, right?
We're going to get there in a minute, Martin. Don't worry
about it.
Yes. Well, in the Apple ecosystem, the sales figures of something called the Lisa
of small relevance.
Exactly, in comparison to the Macintosh, paled. Let's put it this way. So the Lisa tanked, and the the Macintosh had some. Let's put it this way: small success in comparison to the IBM PC and friends. Of course, the fact that IBM, to some extent, opened up their system to allow cloners get in on the game, of course, helped helped certainly, let's put it this way. Because you would get IBM PC clones and XT clones and AT clones as an advanced technology, as in the successor of the original PC, left, right, and center. Apple, in contrast, was a closed system. Apple never opened up the IP, the interfaces to their systems, so you couldn't clone them. As a matter of fact, Apple, still is, by the way, is very peculiar about third-party software running on their machines, never mind opening up the specifications of set MacBooks or of set Macintosh or whatever. It's still a closed system. Even more so with the recent addition of something called Apple Silicon, because this is really a closed system. But I'm digressing. Okay, back into the 80s. As Martin rightly observed, in comparison to the sales figures of IBM and friends, Apple wasn't doing too well. As a matter of fact, they made quite a few mistakes, one of them ousting a certain Steve Jobs from the board of Apple Computers. Funny enough, a company he originally founded with a guy called Steve Wozniak, but we're talking 70s now. So Steve Jobs went off to set up his own company called Next Computers. The idea was to provide a high-spec, high-value workstation to mostly the educational markets. The trouble is, the Cube, as it was called, was quite a good machine, but lacked one feature, an operating system.
Didn't they write them own?
Well, no. Okay. They took things that already existed and put something on top of this.
Put a name on it. Yeah. Okay.
So if you take a look at something called Nexus, which was essentially the operating system running on said Next computers, you're looking at a microkernel, a GNU userland, and a proprietary GUI. And that hasn't really changed since then. Okay, fun fact. The few people who didn't go from Carnegie Mellon University, as in the Mark III project, who didn't go to Microsoft, joined a company called Apple. Because Steve Jobs was quite convincing for them to join said company. After he sold Next Computers to Apple back again, late 80s. Apple at the time saw this as a way out of their conundrum. Apple was tanking. Next had some initial success with the computer, with a line of education computers. So Mr. Scully thought it might be a good idea to bring Steve Jobs back into the company. So essentially, he made Steve an offer he couldn't refuse. A few dollars changed hands. Never mind the fact that Steve Jobs was offered the position as an interim CEO to run Apple once again. Something that he couldn't refuse. Hence, this new thing called Macintosh was born once again, now running, in contrast to something called OS 9, a new operating system, like an adapted next OS called OS X, like OS 10, that had, in contrast to OS 9, true multitasking and some other benefits. Fast forward, about 20 years later, Apple and Microsoft
What year are we now?
Late
Sorry.
10s.
Okay.
Well, actually make that 2005, 2004, something like this.
2005, okay. Yeah.
Yes, 2005, 2004. Steve Jobs already had caught on to the fact that the desktop market is quite limited, never mind the server market, if you are playing the league below IBM with their big R and all the rest of it. Plus the fact that Apple still at the time was pretty expensive. So around early 2000s, I reckon, Jobs had this brilliant idea of turning a computer manufacturer in something called a marketing front. And that was one of the jobs he excelled at. So the notion of iPads, iPods, and all the rest of these gadgets that Apple really kind of used to save the company, that was a smart move by a certain Mr. Jobs to turn, I'm always tempted to say, an ailing hardware manufacturer into a lifestyle company. Hence the new Apple was born. Now, at the time, and I'm digressing here a little bit, but it will click into place in about 5 hours when I've come to the conclusion of this episode, but don't worry about it.
I think we're probably looking at a mini-series rather than an episode.
At the time, a certain Andrew Rubinstein had come up with the idea of putting a small computer into everybody's pockets. Funny enough, he named this little computer an Android. Steve Jobs had pretty much the same vision. He imagined that the phones that you could get at the time, like the Blackberries and all the rest of them, had one feature missing. You could only phone people with them. Maybe you could read mails, but that was pretty much as far as it went. The idea that both people had is, why not put a very small computer that is able to run apps as in applications into everybody's pocket at a price? Andrew went down the route of adapting something called Linux as the basis for his Android operating system, whereas a certain Mr. Jobs decided that they already had something called macOS, or also known as OS 10, and simply stripped down that version to something called iOS, which was the basis for something called the iPhone, which Apple launched, I think, in 2008 or something like this.
Oh, I can't remember. Yeah.
Kind of late 2010s or something. So the iPhone was essentially running a micro-kernel with a stripped-down FreeBSD personality, because that's exactly what the operating system that the original NextOS still kind of possessed, with the graphical user interface on top of it, still is. So if you're looking at an iPhone today, you're still looking at a kind of tiny Mark III microkernel, simply abstracting away the hardware, then something called a FreeBSD personality, also known as Darwin in Apple lingo, and then some crappy proprietary GUI on top of that. macOS is still the same, hasn't changed. So this is the reason why if you open a terminal on any OS X machine for at least for the last 14 years, 13 years, essentially, you're looking at a BSD system. Mac ports and Homebrew are just BSD package managers. That's the beauty about it.
Uh-huh.
So, kids, grandfather is done talking. I mean, this is the history in a nutshell. These are the two kind of prominent examples for two microkernel technologies that have survived time. Let's put it this way, because Windows NT is still around, now called Windows 10 or maybe even Windows 11, if the current law is anything to go by. I mean, the last DOS-based version that Microsoft did was, I think, Windows ME around 1998 or something like this.
Blimey.
And then after that, you're looking at Windows NT successors, let's put it this way. So if you boot up your Windows XP, if it's around, if you boot up your Windows 7, 8, or 10, essentially you're looking at a microkernel architecture, at a very successfully, from a commercial perspective, I might add, microkernel architecture. Same goes for OS X. So you're using microkernel architectures if you're using any of these two systems. What you're not using, the other way around, you're not using a microkernel architecture if you're running Linux, because Linux is still the monolithic operating system, to some extent, let's put it this way, that Linus thought up about 20 plus years ago. Linux is now called these days a hybrid operating system, let's put it this way, because since early days, you can load something called kernel modules into the kernel. So you can extend the kernel, for example, with entropy generators, with device drivers and all the rest of it. But essentially, it's still a monolithic kernel. In contrast, for example, to something called Minix. So, Andy Tannenbaum, if you're listening, we should probably talk about Minix now, shouldn't we?
We can do.
Care to enlighten us about the Usenet wars, Martin?
Yeah, well, this is really
given the fact that you're half Dutch originally anyway, or 100% Dutch actually.
Well, not 100%, but that's a story for another day.
So I was just about to ask where the rest comes from.
Yeah. So
some other time, yes.
So I think it was Tannenbaum who opened the so-called war, or whatever you call it. He initially said that Linux is obsolete when he first, it's somewhere around 92-ish, maybe.
When
he came up with Minix, right? And he said, now that we have microkernels and we have Minix, Linux is obsolete.
Or Unix, for that matter, I think originally.
I think it was specifically saying Linux, because that's why the reply came from Linus himself, right?
For some strange odd reason, yes.
Yeah, so that's how it started, and then Linus replied about all the shortcomings of Minix, like multi-threading, lack of multi-threading, and whatever. But yeah, that's how it started, and so Tannenbaum's original argument around Minix is that it was able to run on much cheaper, smaller CPUs, right, than a monolithic kernel, which is clearly these days not such an issue, but back in the day, memory and CPU processing power came at a significantly higher cost than they do now. So that was his argument, that with the microkernel you can run it on much smaller footprint systems.
True, and I mean the argument, of course, doesn't hold, because if you take a look at Linux these days, Linux is probably the operating system that can be deployed on the most varied hardware that is on the planet. ARM support entered the kernel in 95. That was a very early smart move, I might add. So since the kind of mid-90s, you could run Linux on an ARM architecture. Of course, Linus, when he devised Linux, had this Intel processor in mind called 386, because at the time that was basically the hardware that he had. But given the fact that quite a few people re-architected this monolithic kernel, essentially, if you take a close look at the structure of the source code, although it's still a monolithic kernel, there's only a small set of hardware abstractions encapsulated, and the rest is portable C. So although from an architecture perspective, it's not a microkernel, the hardware dependencies, like a microkernel, have been pretty much encapsulated.
Yeah.
You can see this if you take a look at, for example, the Wi-Fi device driver architecture. There is a thin layer that encapsulates the hardware specifics of a Wi-Fi NIC, and after that, it's generic 802.11 stack, independent of any device features. And this is the beauty. Of course, there is a little known fact that when it comes down to deployment figures, Linux has actually won the war. Because as common lore goes, Intel took a very close look at something called Linux when they architected something called the Trusted Platform Module. For those listeners who are not familiar with the TPM, if you power up any Intel processor of the last 10, 15 years, something like this, maybe even longer, essentially below the operating system runs another operating system on a different portion of the CPU die called the TPM, the Trusted Platform Module, which is in charge of crypto things, some persistent storage, maybe a web server. Unfortunately, Intel only opened so much of this IP, so the rest is actually speculation. But the lore goes that TPM is just much more than just a hardware module. Details will be in the show notes, but fun fact: Tannenbaum was approached with some specific questions about the Linux code base. He answered these questions, but then radio silence. Some people, way later in history, took a close look and in terms of reverse engineered portions of the TPM code and came to the conclusion that this is something very close to something called Minix. So in the terms of deployment numbers, Minix has clearly won the war in comparison to Linux. Because if you take all of the Intel-based CPUs on the planet into account, you're looking at slightly more CPUs than something called Android that is in everybody's pockets is using or running on set devices as an ARM architectures running inside your smartphone.
Okay.
Still awake, Martin. Excellent.
Yeah, I have some questions, but we'll get to those at some point.
But yes, by all means.
Maybe next episodes.
So what questions are there, Mr. Visser?
Well, okay, so the difference between monolithic and microkernels are quite clear. Now, what are the characteristics, the benefits of one over the other in certain circumstances, like performance, security? Any thoughts on these subjects?
How much time do we have? Another 2 hours? No, to summarize, of course, you do pay an overhead with regards to performance. I mean, this is what you clearly see. And Microsoft made quite a few mistakes here. If you take a look at something called Windows NT version 3.1, where actually the video device driver was separate from the microkernel implementation, you could actually see the window content refreshing and getting a cup of tea. Because it took so long because of the, for example, of the context switches between the different subsystems.
Mm-hmm.
Something they corrected, I think, with 3.5.1 or 4, because they moved the device drivers back onto the microkernel plane, which of course meant lesser context switches and much improved performance.
Mm-hmm.
As usual, security and performance are always trade-off. Hasn't really changed. So the more secured a system is, the lower probably the performance is. This is what you see again when you take a close look at the different versions of the NT. Needless to say, if you move the video driver closer to the microkernel, a bug in any video driver could compromise the microkernel itself, or the personality where it's moved into, depending on how you put it. So this is your typical kind of trade-off bargain. What do you want to have? Do you want to have improved security where you isolate as many components as you can? Or do you want to have a performance system where you basically trade in security to some extent? Needless to say, MMUs in the early days and something called security enclaves in modern systems do help that matter. And I reckon with the advent of more and more virtualization, even in your smartphone, things like security enclaves become more and more important. For the people who don't know what security enclaves is, technology developed, I think, originally by
part 3 of the series.
Yes, I think Intel was the first company to commercialize it anyway. Imagine an address space that is further subdivided into so-called enclaves. These enclaves can only be accessed by certain portions of the code which have the necessary rights. In contrast to MMUs, where an application, once it has acquired the address space, can do pretty much whatever it wants with it. So picture a more secure system powered by additional hardware features, let's put it this way. So you get more security without the additional cost, let's put it this way. The corresponding research goes back to the, I think, late 80s, early 90s, when people already thought about putting more intelligence into something called memory management units, MMUs.
Okay, so going back to the kernel debate, which one is more secure?
I reckon Linux would win the war here. Because if you load a Linux kernel module into the kernel, it has free reign of the kernel in its kernel address space. So a pointer problem can, of course, corrupt kernel data structures. If you corrupt kernel data structures, you might as well power down the machine. In contrast to this, personalities typically run in their own address space. So the connecting medium is actually the queuing systems or any other inter-process communication that the microkernel offers. So it's more secure at a price because you do pay, for example, the context switching overhead.
Mm-hmm. Yeah, so yeah, that covers the performance aspect as well. Yeah, very good.
Something, of course, that will be alleviated with the arrival of quantum computing. But that's another story for another day, children.
Excellent.
And with that, Andrew now, disguised as Mr. Visser, will take us into the boxes. What's your box, Martin?
Oh, blimey. What was it? Why don't you go first after remind me?
Let me guess, lukewarm ale.
No, there was something.
Not really? What has changed? Camera cancelled the membership because you didn't pay your dues? Fair enough, happens to the best of us. What's our box then? Yes, of course. A movie called The Sleepover.
Don't know that one.
Recent one, I think it's from 2020 or something like this. As in typical family comedy. If you're listening to Tobias, credits, because full disclosure, Python Init mentioned this on one of the episodes about a year ago or something, and I simply checked it out, and Tobias is spot on. It's very funny. Essentially, it's about a family that invites neighboring or other kids over for a sleepover. What they don't know is actually that the mom of the family is a secret agent being recruited on her very last mission. And the husband is let's put it this way, wasp, for want of a better expression.
Is it a what?
Wasp. Wasp, yes. White Anglo-Saxon Protestant.
Oh, not a flying animal.
Sorry. and is just drawn into the whole adventure. Very funny. Don't miss it if you're into that sort of family entertainment. It's clean. It's fun. It's hilarious to watch with kids if you have any.
Okay, excellent.
Martin, what's your pox?
Well, I haven't really watched anything for a week.
Well, you could mention a book if you want.
Yes. Well, I can mention a paper because I was quite impressed by it.
A paper, like a newspaper, like the Sun or something. You heard it here first.
Do people read the Sun?
No, Martin, they don't, because that's the reason why it's one of the biggest newspapers in the UK. People simply don't read it, so don't worry about it.
Do people still make physical newspapers?
They do, yes.
Okay. Well, I certainly haven't. Well, yes. When I used to go on a train, 2 years ago, we used to have those free newspapers called the Metro. Yeah, very true, very true. Yes. Oh, yeah, I remember those.
So you read a newspaper and you were thoroughly impressed?
No, I didn't. No, not. It's a research paper.
A research? You read research papers? Why?
Occasionally. Well, to learn about stuff.
To
find out what the current research is on certain things.
Have you started the study once again? Okay. Yeah. Martin, you hear it here first, people. Martin's back to uni.
No.
Hopefully studying something worthwhile this time.
Well, not micro-kernels, no. I think that that war has been dusted.
You were saying you said you read a research paper. May I inquire about the subject?
Oh yes, of course. It's called Parallel Algorithms for Real-Time Route Optimization. Yeah.
It's none of this GPU
parallel algorithm
again, right?
Railway rescheduling. Yeah, that's the one.
What? Say again? Parallel algorithms with what?
For real-time railway rescheduling.
Cameron, if you're listening, get in touch with Mr. Visser. Inside joke.
What's it got to do with beer?
Nothing. Don't worry about it.
Okay. I didn't know Cameron were into railways, but there we go.
Sorry, Cameron.
Cameron. Oh,
yes.
my friend Cameron. Yes. Indeed. Well, yeah. Anyway.
So, what about then?
Well, it's about algorithms for real-time railways. You should be scheduling. Strangely enough. So, no,
it's enlighten us about the details.
it's rather well done, which is why I mention it. I mean, there's obviously many people who write research papers about lots of different things.
Hang on, Martin. Let me put this into perspective. I mean, Trainspotting was quite a cool movie, granted, but the original Trainspotting is quite different. I'm led to believe. So I reckon that this algorithm paper is pretty much the next step, no? Actually, it will put you to sleep instantly rather than after 2 minutes.
It's only 180 pages. So, yeah.
A research paper, okay.
Well, it's actually putting together lots of other research as well. So from that point of view, it's what I meant.
It's ripping off current research, okay.
It's combining previous research and adding to it. Indeed. But yeah, so if you're
like ripping off, okay, I get it. Yes.
That's open source for you, isn't it?
Absolutely, fair enough. As long as you quote it, nothing wrong with it.
Indeed. Yeah, so there you go. So if you want to learn about how to reschedule railway tables,
details in the show notes.
Algorithms.
If you're suffering from insomnia, that is the place to go to, just in case.
In case you made it to this end of the episode.
If you're still awake, can't get to sleep, take a look at this research paper.
There you go. A handy tip for the insomniacs.
I'm so inclined, yes. And with that, people, thank you for listening. And of course, as usual, before I forget, yes, of course, We don't have feedback, but we like to thank Hacker Public Radio for hosting us.
Indeed.
For almost 1.5 years. Ken, thank you very much. And of course, if you want to send feedback, Claudia or not, the address is feedback@linuxinlaws.eu. Microsoft, IBM, Apple, if you want your name mentioned more often on the show, the address is sponsor@linuxinlaws.eu.
And if you want
Just get in touch.
If you want an episode on glass painting, likewise, get in touch with feedback.
Yes, if you want to keep Martin happy, just send an M1 to his address. We'll be more than happy to share the details. Just send a message to sponsor@linuxinlaws.eu.
Indeed.
Thanks for listening and looking forward to having you around for the next episode.
This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, Tab Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for the song Salute Margot, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under Creative Commons at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
Yeah, I'll need to sort out my audio as well. Bear with me.
You can try one of these semi-open source operating systems. Also known as macOS or something, I don't know.
Oh, is that a semi-open? Okay.
Yes, it's semi-open. We will go into the details in a minute, Martin, don't worry. Yeah, my name is Dave Cutler. Actually, I was in charge of something called VMS. Yes. And then I ventured to the dark side like so many others.
One of my favorite operating systems.
Martin, if I do this whole liquid professional will become lukewarm, and that's the pleasant side. I mean, of course you wouldn't know because you drink it lukewarm all the time.
It depends what you call lukewarm. You want to do the intro?
I mean, no. Well, you have to restart the recording first.
Oh,
no?
I have to start recording. What a good idea.
Yes, Martin, it would come in handy.
That would be annoying, wouldn't it? Spent the whole episode non-recording.
Martin, and if you would have bothered to take a look at the calendar, it would have said behind glass painting episode.
Okay.
But not to worry, I'm flexible enough to basically go back to micro-kernels anyway. No worries.
Good. Glad to hear it.
So, Mr. Tannenbaum, if you could do your magic and start the recording, that would be greatly appreciated.
Find the right window first. Hang on.
Maybe you could run Linux instead of Linux.
Let's see.
Welcome
right
to
then, Mr. Cutter. Good evening.
My POX of the week is a movie called Taking Lives.
Hang on, didn't you have that last episode?
Sorry, we have to cut this out. Well spotted, yes.
Okay.
Oh, blimey. I'm really getting old. What's our POX then?
Hey?
I can't remember. Yes, of course.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.